Okay, so we're going to cover just a few more things with simplifying radical expressions. So adding and subtracting, these examples you've seen before, so just with numbers. We know if we simplify all of these radicals down and we get like terms inside the radical, then we can combine like terms outside the radical. So square root of 108 simplifies to... So my method for simplifying these is I find the largest perfect square factor. So 108 is 36 times 3. And since I find the largest one all the time, then I never have to do extra work. So that comes down to 6 root 3. Square root of 75. 75 is 25 and square root 3. So now we have minus 5 root 3. And then 44 is the square root of 4 times the square root of 11, which is 2 square root 11. So since these two have the same term inside the radical, then we can combine like terms here. And what we get is so 1 root 3, so just root 3. And then this one is not like terms, so I just have to leave it by itself. So root 3 plus 2 root 11. So now we'll apply the same properties to an expression that has variables. We have to be careful because the combining like terms here is a little bit trickier because we have to make sure that all the variables and the radicals are the same. So square root 4ab squared, so square root of 4 and the square root of b squared, those are perfect squares. So I can bring those outside the radical, so 2b, and then square root of a inside the radical. B times square root of 4a. So square root of 4 is a perfect square. So that one I can bring out. So now it's 2b. And then I have square root of a inside the radical. In this third one, so 16 is a perfect square. So I can bring that out as a 4. And then a cubed, remember that's a squared times a. So if I'm doing the square root of all that, I can bring this one outside the radical as a, but then the other a has to stay inside the radical. So now when I combine like terms here, I have to be careful. So I'm looking at, they have to have the same radical, which all of them do, but if there's any other variables attached to the radical, those also have to be the same. So this is actually, my term would be b root a, and then here I have another term that is b root a. So those I can combine as like terms to give me 4b root a. But the other term is 4a, so I can't combine the b with the a. So I'm just going to leave that as plus 4a root a. Okay, so that's really all there is to it when we're adding them. We still simplify and then we just look for like ones. Now multiplying and dividing radicals. So here we see 2 minus root 7 times root 3 plus 2. So this is just the same as multiplying something like 2 minus x and then x plus 2, right? We're going to use the exact same method. So you could use the FOIL method or the box method. I am a recent convert to the box method, so I'm going to do that one. So we have 2 and then minus root 7. And on the other box we have root 3 and a 2. So in this first box here, I have 2 square root 3. And then in this box, I get a 4, 2 times 2. In this box, I get root 3 times root 7, which is square root of 21. And then in the last box, I get 2 times minus root 7, so negative 2 root 7. So altogether, I have 2 root 3 plus 4 minus 2 root 7 and plus square root of 21. And none of these are like terms, and none of them can simplify. So square root of 3, square root of 7, and square root of 21, none of those can be simplified. So this is just our final answer. Right? So in some ways it's easier than doing FOIL with variables, because then you have to look for like terms to combine, and here you don't always. So number 4, now we have 5 divided by square root 2x minus 5. So in this one, remember, we still don't like radicals in the denominator. And in this one, if we tried to do this method, so multiplying by square root 2x over square root 2x, don't write that down because we're about to erase it. So I would have to distribute that square root of 2x to both terms in the denominator. So it would, if I multiplied it by that, the radical goes away. But now I get a radical on that one, so it doesn't help me. So what we do here is a thing called multiply by the conjugate. So there is a useful fact about radicals, really about anything. So I'll write it over in this area below this problem. So if you have something like square root of a plus square root of b, and you multiply it by square root of a minus square root of b, then all of your radicals will cancel each other out. You end up with, well, you'll see over here. So what we're going to do is multiply by the conjugates to the numerator and denominator. So in this problem, the conjugate is going to be square root of 2x plus 5. So it doesn't matter that only one of those things is a radical. So when I do that, if I multiply, so I have 5 over square root of 2x minus 5. I'm going to multiply the numerator and the denominator by square root of 2x plus 5. So for the numerator, we can just distribute. So we'd get 5 root 2x and then plus 25. For the denominator, let's go ahead and use the box again. So we have square root of 2x and plus 5, and then square root of 2x minus 5. So in this first box, I have square root 2x times square root 2x. So because it's a square root times itself, we're just going to get 2x. In this box, I get minus 5 times square root 2x. In this box, I get positive 5 times square root 2x. So we can see already the term in this box is the negative of the term in that box. And that's going to be our radicals that cancel out. And then in the last one, I get minus 5 times plus 5, so that's negative 25. So yeah, if we combine like terms, the 5 root 2x and the negative 5 root 2x will simplify, and this is just going to give us 2x minus 25. And then that is our denominator, and we are done.